Alright, hello everyone, welcome to this video where we have this special products of algebraic expression, and we are going to try out each special products, which you may consider them to be like a formula. So for the first one, where we have a plus b bracket square, this simply means that we are actually multiplying a plus b by a plus b. So if I were to write it down here using the multiplication frame, it will be positive a, positive b, positive a, and positive b. And I'm going to multiply them together, meaning a times a is a square, a times b is ab, a times b again is ab, b times b is b square. And if I were to use the distributive law of multiplication, where I will have a times a, they will give me the same answer. Multiply a times b, multiply, I will have positive ab, positive b times a, and a times b is the same. And I would have positive b square, and eventually the a, b are like terms, and I would have this identity or formula that we could use if we see a plus b bracket square. We can just substitute into this formula. Alright, so let us look at another special products, a minus b bracket square. Again, it is a minus b times a minus b. So if I were to use the distributive law of multiplication, I multiply, I will get a square. Positive a times negative b will give me negative ab. Negative b times positive a will give me negative ab again, and negative b times negative b will give me positive b square. And after I simplify the like term, negative 1ab minus 1ab, there will be 2, negative 2ab, and positive b square at the side. If I were to use the multiplication frame, I will have a and negative b here, a and negative b here, and when I multiply them, I will get back the same answer. A times a is a square, a times negative b is negative ab, a negative b times a is negative ab, negative b times negative b is positive b square. And so that will be the formula or identity for a minus b bracket square. As I move on to the third and last special product. Now, this is really special because it is no longer a plus b bracket square or a minus b bracket square. It is a plus b times a minus b, and let's see what will happen, okay? A times a will be a square. A times negative b is negative ab. Positive b times positive a, positive ab. Positive b times negative b, negative b square. And notice what happened. Negative ab plus ab, this one will become, yes, this will become 0. So when it is 0, we don't have to write it anymore. And we actually get this special product. So I'm going to make one of the too many equal sign already, okay? So this one I'm going to just make it into one equal sign. Alright? So that would be the last part. And if I were to use the multiplication frame, I would also get back the same answer. If I have a plus b, which is positive b, a and negative b, and when I multiply them, I will get a squared. This is positive ab, this is negative ab, and this is negative b squared. And we actually have three different identity. A plus b bracket square is equals to a square plus 2ab plus b square. A minus b square is equals to a square minus 2ab plus b square. And strangely enough, a plus b times a minus b is equals to a square minus b square. And sometimes the textbooks or the notes of the assessment books refer them to difference, do take note of the typo error, of 2 squares. And the last part is a misconception that students actually thought that a plus b square is equal to a square plus b square. So do take note, they are not equal. Not equal. And how do we prove that? This is the proof. Example, if we put 3 plus 4 bracket square, 3 plus 4 is 7. 3 plus 4 is 7, and 7 square is 49. But if I do 3 square plus 4 square, 3 square is 9, 4 square is 16. I add them out, it's 25. And these two are not equal to each other. Alright? So using the same logic, a square minus b square is also not equals to a square minus b square. And if you want more example, I could do the same as well. I could have, for example, two plus 1, 2 minus 1 bracket square is equals to 2 minus 1 is 1. So 1 square equals to 1 times 1 is 1. Then, but 2 square minus 1 square. 2 times 2 is 4. 1 times 1 is 1. This one is actually equals to 3. So 1 and 3, they are again not equal. Okay? So please remember, a square, a plus b bracket square does not equal to a square plus b square. Similarly, a minus b bracket square does not equal to a square minus b square. With that, we have come to the end of this video. If you like this video, do give it a thumbs up. Thank you for watching. Have a nice day.